So today we'll be discussing about ones, I, zeros, arrange, reshape, concatenate, delete, transpose, random.rand, random.rand, random.rand int, linspace, and that's it. So these are the functions that we're gonna see today. All right. So let's do it one by one. So what is this once function? You can create a one-dimensional or two-dimensional arrays with only one number in its element. Okay. So now let's see. I give as 1 is equal to np dot ones of 5. np dot ones of 5. Now let's see 1. So if you see 1, you have an array with all 5s, and in Jupyter the default printing of this will be floating points, guys. So don't get confused why it is printing 1 point something like that. So it is the default showcase of all the print statements in Jupyter. All right. So now if you want to create two-dimensional arrays, so you can directly use one np dot one is dot in a tuple, give the shape of the array. For suppose I want 4 comma 5. That means 4 columns, 4 rows and 5 columns with all the elements as 1. So if you just see this 1, then you can see there are 4 and 5 columns of all the ones. Now if you want to put all 5s into 5, all 10s into 10. All right. So this is what about ones. Now I have another one which is zeros. Zeros is also same functionality, but in the place of 1, you will have all the elements as zeros. So 0 is equal to np dot zeros of 6. If you see 0, then you can see all the elements as 0. In the same way, if you want to create two-dimensional in a tuple, give the shape. Let's give as 3 comma 3. Now C0, you can find all the zeros got created in 3 by 3 matrix. This is 0 and this is 1. We have another function called I. Let's see what's that I does. I is equal to np dot I of 3. If you see, it is creating an identity matrix of 3, 3 rows. 3, 3 rows. If suppose you give 4, it gives 4, 4 shape of identity matrix. Let's suppose I give in this way. It creates 4 rows and 5 columns of identity matrix. So 0 is used to create a matrix of 0 elements. 1 is for matrix of 1 element. I is for creating an identity matrix. Chalo. Now I have another function called arrange. Let's see what is this arrange doing. What I do is I'll just create a variable arr is equal to np dot arrange of 10 arr. So if you see that an array of 10 elements are created from 0 to 9. So you have seen the range function, right? So range function is creating a sequence of numbers from 0 to the number given, right? So here also arrange will arrange the array with the help of the number which is residing in its argument. First, suppose if you want to give a start and stop one. Now, if you want to give the start and end number, at that time you can give 10, 30. Then it is creating a number from 10 to 30. For suppose if you want to give a step size, so just if I give 5, you see this, you can find numbers with step size of 5 is created. So this is what arrange function does. So likewise we have arrange function, we have linspace. So let's see what is this linspaces. Linspace is used to create an array of evenly spaced numbers over a specified interval. Yes, you can. I'll tell you that, Krishnavamsi. Just wait for a minute. You can do it. Now I have a linspace. Linspace is used to create an array which returns evenly spaced numbers in a given specified in a given interval. So let's see how it is happening. So ARR is equal to NP dot linspace of 0, 10. Let's see, I'll give 0, 10. If you just see array, it will create some elements which are linearly spaced between 0 and 10. Now I want to create only 5 numbers from 0 to 10. So I'll just give the number of numbers that are to be created. So if I give this, only 5 numbers will be created. 5 linearly spaced numbers will be created. 0, 2.5, 5, 7.5, 10. If suppose if I give 20 numbers will be created between 0 and 10. If suppose I give 100 elements which are linearly spaced between 0 and 10 will be showcased. So in arrange, 5 is the step size. In lin space, 100 is the number of elements that you want to create. So did you understand the difference between this and this? So these are the same thing. Now if I want to change the start and stop, this is about lin space. Now let's talk about random rand and random dot rand int. Likewise, you have arrange. You will also have random dot rand np dot random dot rand of 2. So if you just execute this, it will create 2 random elements in a one-dimensional array. 2 random numbers in a one-dimensional array. And the range that will be created is, the range of the elements that gets created are lying in 0 to 1. So how many, if you take 10 or 20 or 30 or 40, all the elements will be randomly generated in the range of 0 to 1. Now if suppose you want to create a 2-dimensional array from this, so at that time you can directly use 4, 5. So that means it gave 4 rows and 5 columns of random numbers. So random dot rand is used to generate a random number array lying between 0 to 1. So here you are getting the floating points, right? So instead of that, you can create an integer array. So np dot random dot rand int of 10. So if I give 10, it will randomly generate one random number between 0 and 10. For suppose I give 0, 5, 10. 0, 5, 10. So this means I would like to create a one-dimensional array of 10 random elements between the range 0, 5. So have you seen this? So now 10 elements created which are randomly generated in the range of 0, 5. So this is about rand int. So here rand int, arrange, linspace, every that 3 functions are creating only one-dimensional array. One-dimensional array. Okay, fine. So if suppose I give 20, if suppose I give 20 over here, it will generate a random number which is lying between 0 to 20. If suppose I give 100, if suppose I give 100, it will generate a random number lying between 0 to 100. So first time it generated 35. Again, I'll execute it. It is generating 24. Again, I'll generate it. It is 86. Again, I'll generate it. It is 87. So randomly, it will generate any number, any random number between 0 to 100. For suppose you want to create a random numbers in a range of 5 or 6. So I'll give a range. The starting number is 4 and the ending number is 10. And I want to create 5 random integers. So if you just execute this, so this 5 is the number of elements that will be created. And what is the random range? It can be between 4 and 10. All right, Vaishnavi. This is random.randint. Now, all this random.randint, linspace, and arrange are used to create one-dimensional array. Okay. I want to convert that one-dimensional array to two-dimensional or multi-dimensional array. So at that time, you will be making use of another function which is rename. No, we cannot change the value, Jiva. In random function, the random.random will give the values which are ranging between 0 to 1 only. You cannot change that. Now what I do is, I create an array np dot arrange of 10 comma 40 comma 16. If you see array, I'll get oops, this is step size, I'm sorry. One comma 16, let's suppose. If you see, it created the numbers from it created 16 elements in an array. Now I want to reshape it. So I will be using a function, the function called reshape, which is arr dot reshape of 4 comma 4. If you see this re, then the one dimension array got converted into two dimension array with 4 comma 4. And remember, this 4 comma 4 or any numbers which are here should be the multiples of the number of elements. So here I have 16. Yes or no? So the factors of 16 could be 1 into 16 or 16 into 1 or 8 into 2 or 2 into 8, 4 into 4, like that. Yes, so you can give only these values in the reshape function. So you can give 2 comma 8. That's fine. 8 comma 2 is also fine. But if you give 5 comma 4, 4 comma 5 or 5 comma 4, it gives an error. So cannot reshape an array of 16 into 4 comma 5. So if you reshape that into 4 comma 5, so you'll get 20 elements. We don't have 20 elements in this array. Yes or no? So based on the count of this elements in an array, you have to reshape it with the factors of that particular count. So as it has 16 numbers, I am giving it as 4, 4. All right. So here you have used arrange, right? You can also use linspace. You can also use random dot int. Anything can be used, and you can reshape that to the two-dimensional array. Two-dimensional array. Now let's go to some other functions, which are concatenate, delete, transpose, etc. So first, I will talk about concatenate. Okay. So what is this concatenation? So what do you mean by string concatenation? What do you mean by string concatenation? For suppose I have s is equal to hello, p is equal to hi. And if I want to use s plus p, it says hello, hi. So you're joining two strings here. In the same way, concatenation is nothing but adding or joining two different array elements into a single array. So let's see how it is happening. So first I'll take A is equal to np dot arrange of 0, 9 dot reshape of 3, 3. P is equal to np dot arrange linspace of 0, 9, 9 dot reshape of 3, 3. So here what I am doing is I am creating an array with 9 elements, and I'm reshaping that array to three rows and 3 columns. Here I am creating 9 linearly spaced elements in the range of 0, 9 and reshaping it with 3, 3. Now let's see A as well as B. So I have these values. Now I want to concatenate these two. I want to concatenate these two. How can I concatenate? C is equal to np dot concatenate of, in a tuple, give the values that you would like to concatenate. A, B. Now just click C. If you see, all the values are concatenated. So you have 0, 1, 2 as first row, 3, 4, 5 as second row, 6, 7, 8 as third row, and the B rows are concatenated in a row wise. But I want to concatenate these with respect to columns. So at that time, what you do is you just give something called axis comma axis is equal to 1. So if you see, B got concatenated with respect to columns. So if you don't give any argument of axis, then by default, the rows get concatenated. If you give axis is equal to 1, columns get concatenated. So this is what concatenate is. This is what concatenate is. All right. Let's see the function delete. First, suppose I want to delete the first row. I want to delete the first row. Okay. So at that time, what I do is, first row is 0, 1, 2, 0, 1.125, 2.5, right? So what I do, np dot delete of 0. Oh, wait, what am I supposed to delete? I want to delete D, okay? So D, comma, 0th row. So what happened? The 0th row is deleted. 0th row is deleted. Now if I want to delete any column, for that I have to just use comma axis is equal to 1. If you see, the first column got deleted. So did you understand this? Now if you want to delete different rows, different columns, for suppose I want to delete second column and third column. Second column and third column. So at that time, what I just take a list and I will write the column numbers. It will be 2 and 3. So if you just execute this, column 2 and 3 got deleted. Column 2 and 3 got deleted. Have you seen this? If you don't write axis is equal to 0, axis is equal to 1, then that means it is row wise deletion, Tulasi. All right. Okay. This is delete function. Now we have transpose. So you might have known what transpose in matrix, right? So converting columns to rows and rows to columns, the same thing. So for suppose I want to convert this D into transpose. So I give D dot or C. Let's see C. C dot transpose. All the rows got converted into, rows and columns got transposed. So this is transpose function is. And we have two more important functions which are ravel, flatten. So as I already told you, the two important functions that we are supposed to learn are flatten as well as ravel. Okay. So let's see what are this flatten and ravel. Flatten used to convert multi-dimension to one dimension. Ravel is also used to convert multi-dimensional to one-dimensional. Both are the same thing. But let's see what is the difference between these two. Okay. So first, let's have C. So we have C, right? So in C, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1.125, 2.25, something like that. Yes or no? Now, I will create another variable E is equal to C dot flatten. Now, if you see E, this two-dimensional array got converted into one-dimensional array. This two-dimensional array got converted into one-dimensional array. Now I'll take another variable f is equal to c dot ravel. If you execute this, if you just see this f, Same. 2 dimension got converted into one dimension, right? Now, what is the difference between this flatten and ravel? The thing is, this you can consider as the main data. This is resultant from flatten. This is resultant from ravel. Now, what I do is, I will change some content from this F. So this F is resultant from ravel, right? Now here I want to change this 2. So here I have 0th index, first index and third index. All right. So what I do is F of 3 is equal to 1000. F of 3 is equal to 1000. So even in C we have this 2, right? So let's see, F of 3 is equal to 1000. Now what I do, I'll just execute this. CF, okay, 3 is this, I'm sorry. So I'm converting 4. I mean the fourth number as 1000. So yeah, it got converted. Let's see the same is getting converted in C or not. So here 4 is, obviously it's like that itself. Yes. What I'm doing is, now let's see C. Here C, the 3 number got updated as 1000. So whenever you do modifications to the array which is resultant from ravel, the modifications will be reflected in the main data also. But if suppose if you change any content from E, so I want to change this first one, 0th index is as 999. So F of 0 is equal to 999. Let's see F. Yes, F got converted. The F has the modification. But let's see the modification is there in C or not. C. I'm sorry, F is ravels, right? So you have to do E. I'm sorry. E is equal to 1449. Now C, it didn't get converted. But if you say F, E, it got converted. Have you seen this? So now did you understand the difference between ravel and flatten? So I'll tell you again, guys. So first suppose I have a main array which is C. Okay. Now this is a multi-dimensional array. Right? Multi in the sense 2-dimensional array. I want to convert this multi-dimensional C to 1 dimension. So I will be using either flatten or ravel. So let's see it again. So I'm just again creating C. So if you just call this C, this is C, okay? C is having 2 by 2 array. Now what I want to do, I want to convert this 2 dimension into 1 dimension. So I can either use flatten or ravel. Now I'll just create a variable E and I'll convert the 2-dimensional array into 1-dimensional array. So now if you see E, it got converted, right? Now I want to use ravel. I've created a variable and I've created ravel. So with the help of ravel, again I converted that into 1-dimensional array. Now what I did is I have modified the content of F. So the index of 3 is the number 3. Now here what I am doing, I am appending 1000 in the place of 3. So whenever I append 1000 in the place of 3, that gets modified in the ravel array as well as it gets reflected in the main array. Can you see this? 1000 and 1000. But coming to the array which is done with flatten. So I've taken flatten in E, right? So what I want to do is I want to modify the function of E. So E of 0 is equal to 1299. Just execute this. CE 1299, it got replaced. But this modification will not be taken place in the main array. Just see C. Did you see that modification with flattened array? No. So whatever the modifications that you do for flattened array will not get reflected. The modifications will not get reflected in the parent array or the main array. But with Ravel, if you do any modifications, the modifications will also be done to the main array. Understood, guys? So these are all about functions of arrays, guys. Now we have some other functions also like c.min, which will give minimum number of the C. C.max, which will give the maximum number in the C. We also have C.argmax, which gives the index of the maximum number, C.argmin, which give the index of the minimum number. So here the minimum number is 0, which is lying in the first row. So that's the reason it is given as 0. But why is this argmax given as 3? It should be 1. Okay, 0, 1, 2, 3. Okay, it is taking index of like this, guys. 0, 1, 2, 3, 4, 5, 6, 7, 8, like that. So the minimum number is lying in the 0th index. The maximum number is lying in the 3rd index.